Hello children, my name is Nikita, a teacher from St.JOSEPH'S Academy, Ghaziabad. Today I am going to explain you one of the topic from 12th class mathematics book, inverse trigonometric functions. Trigonometry is a part of geometry where we learn the relationship between angles and sides of right angled triangle. In class 11th, already you have learned about trigonometric functions and the formulas, in which trigonometric ratios like sine, cos, tan, sec, cosec, cot, these trigonometric ratios you have already studied. Similarly, we have inverse trigonometric function, in which inverse trigonometric functions can be written as sine inverse x, cos inverse x, cot inverse x, tan inverse x, cosec inverse x, sec inverse x. So now we are going to learn the formulas related with these inverse trigonometric functions. If we have a function y is equal to fx and x is equal to gy, then the inverse function is written as g is equal to f inverse, where y is equal to fx means value of x will be equal to f inverse of y. Similarly, in inverse trigonometric functions, if y is equal to sin x, then x will be equal to sin inverse of y. Similarly, restored trigonometric ratios can be expressed in the form of inverse trigonometric ratios. Now, we have a list of inverse trigonometric functions with their domain and range values. Sin inverse x domain is -1 to +1. So, its range will be minus pi by 2 to pi by 2 in closed interval. Cos inverse x domain is -1 and 1 included. So its range is 0 to pi in closed interval. Tan inverse x domain is all real numbers. So its range is from minus pi by 2 to pi by 2 in open interval. Cot inverse x domain is real number. So its range is 0 to pi in open interval. Open interval means boundary points are not included, and closed interval means boundary points are also included. Sec inverse x domain is all real numbers excluding -1 to +1. So its range is 0 to pi closed interval excluding pi by 2. Cosec inverse x, its domain real number, all real number excluding -1 to +1. So its range is minus pi by 2 to pi by 2 closed interval excluding 0. Now, in inverse trigonometry, we have a lot of number of formulas. So, all these formulas have been categorized in different type. So, here we have first type of formula like sine inverse x will always be equal to x. Sine and sine inverse will neutralize to each other. They will give the value as x. Similarly, restored trigonometric ratios like cos of cos inverse x will also be equal to x. Tan of tan inverse x will be equal to x. Cosec of cosec inverse x will be equal to x. Sec of sec inverse x will be equal to x. Cot of cot inverse x will be equal to x. Second type of formula in which sine inverse of sine theta will be equal to theta, where theta will belong to the particular range minus pi by 2 to plus pi by 2 in closed interval, which is well defined for sine trigonometric function. Similarly, for rest all inverse trigonometric ratio, same concept will be applicable, like cos inverse of cos theta will be equal to theta, tan inverse of tan theta will be equal to theta, cosec inverse of cosec theta will be equal to theta, sec inverse of sec theta will be equal to theta, cot inverse of cot theta will also be equal to theta. Third type of formula is sine inverse of minus x is equal to minus sine inverse x. Cos inverse of minus x will be equal to pi minus cos inverse x. Tan inverse of minus x will be equal to minus tan inverse x. Cosec inverse of minus x is equal to minus cosec inverse of x. Sec inverse of minus x is equal to pi minus sec inverse x. Cot inverse minus x is equal to pi minus cot inverse x. The next type, fourth type of formulas, sine inverse x plus cos inverse x will be equal to pi by 2. Tan inverse x plus cot inverse x will be equal to pi by 2. Similarly, sec inverse x plus cosec inverse x will be equal to pi by 2. Fifth type of formula, sine inverse 1 upon x is equal to cosec inverse x. Similarly, cosec inverse of 1 upon x will also equal to sine inverse x. Then cos inverse 1 upon x will be equal to sec inverse x. Tan inverse of 1 upon x is equal to cot inverse x. Then sixth type of formulas, tan inverse x plus tan inverse y will be equal to tan inverse x plus y upon 1 minus xy, where the product of x and y should be less than 1. Similarly, tan inverse x minus tan inverse y will be equal to tan inverse x minus y upon 1 plus xy, where the product of xy should be greater than minus 1. Sixth type formula is one of the most important formula which will be used in maximum number of questions. Seventh type of formula is in which 2 tan inverse x can be converted in the form of sine inverse, cos inverse, tan inverse. So first part, 2 tan inverse x is equal to in the form of sine inverse of 2x upon 1 plus x square. Part 2, 2 tan inverse x is equal to in terms of cos inverse, which is cos inverse 1 minus x square upon 1 plus x square. Third part, 2 tan inverse x is equal to in terms of tan inverse of 2x upon 1 minus x square. Part 3 is most commonly used in question. Now type 8 formulas. 3 sine inverse x is equal to sine inverse of 3x minus 4x cube. 3 cos inverse x is equal to cos inverse of 4x cube minus 3x. 3 tan inverse x is equal to tan inverse of 3x minus x cube upon 1 minus 3x square. Ninth type, sin inverse of x plus sin inverse of y will be equal to sin inverse x under root 1 minus y square plus y into under root 1 minus x square. Similarly, sin inverse x minus sin inverse y will be equal to sin inverse x under root 1 minus y square minus y into under root 1 minus x square. Type 10, cos inverse x plus cos inverse y will be equal to cos inverse of xy minus under root of 1 minus x square multiplied by under root of 1 minus y square. Similarly, cos inverse x minus cos inverse y is equal to cos inverse xy plus under root of 1 minus x square into under root of 1 minus y square. Now, here these are the graphs of inverse trigonometric functions. First of all, graph of y is equal to sin inverse x. The graph of sin inverse x lies between -1 to +1 on x-axis. Similarly, the graph of cos inverse x also lies between -1 to +1 on x-axis. Graph of tan inverse x goes up to infinity. This will be parallel to two lines y is equal to pi by 2 and minus pi by 2 and meeting to these lines at infinity. Now I am going to explain the concept of inverse trigonometry with the help of few solved examples here. Here we have first question, determine the principal value of cos inverse minus 1 by 2. For the solution, first of all we will assume y is equal to cos inverse minus 1 by 2, which can be written as cos y is equal to minus 1 by 2. Now we know that minus 1 by 2 is the value of cos 2 pi by 3. So cos y will be equal to cos 2 pi by 3. Now we will check whether this value lies in the range of cos inverse function. The range of cos inverse function is closed bracket 0 to pi. So 2 pi by 3 belongs to this interval 0 to pi. So 2 pi by 3 will be known as the principal value of given term cos inverse minus 1 by 2. Second question, prove that sin inverse 8 by 17 plus sin inverse 3 by 5 is equal to tan inverse 77 by 36. For the solution of this, we will use its LHS and we will show that LHS is same as RHS. So, LHS is sin inverse 8 by 17 plus sin inverse 3 by 5. Now, first we will change sin inverse 8 by 17 into the trigonometric ratio 10. So, for this we can use the right angle triangle ABC. In this right angle triangle, sin inverse 8 by 17 we have to change tan inverse function. So the perpendicular AB will be considered as 8. hypotenuse 17 will be considered as side AC. So by applying Pythagoras theorem, we are getting BC side as 15. So tan trigonometric ratio is perpendicular upon base. So tan inverse will be 8 upon 15. Similarly, sin inverse 3 by 5 will be changed to tan inverse by using another right angle triangle, which is PQR here. So again, sin is perpendicular upon hypotenuse. So side PQ will be 3 and side PR will be 5. So by using Pythagoras theorem, QR will be equal to 4. Now tan is perpendicular upon base, so tan inverse 3 by 4. Now we will use the formula tan inverse x plus tan inverse y. So it will be equal to tan inverse of x plus y upon 1 minus x into y. So we will put the values of x as 8 by 15 and y as 3 by 4. So on taking LCM and simplified, it will be tan inverse 77 upon 36, which is same as RHS. Hence it is verified. Question 3. Prove that 2 tan inverse 1 by 2 plus tan inverse 1 by 7 is equal to tan inverse 31 by 17. So here is the solution. 2 tan inverse x, first it will be converted in the form of tan inverse by using the formula of 2 tan inverse x, which is tan inverse 2 into 1 by 2 upon 1 minus 1 by 2 square, which will be equal to tan inverse 1 upon 3 by 4. On doing reciprocal, it will be tan inverse 4 by 3. So now it is tan inverse 4 by 3 plus tan inverse 1 by 7 as it is. Now we can apply tan inverse x plus tan inverse y formula. So tan inverse x plus y upon 1 minus x into y. We will put the values of x and y as 4 by 3 and 1 by 7. So on simplifying it, it is tan inverse 31 upon 17, which is same as RHS. Now in question number 4, we have to solve the given equation for x. The equation is sin inverse x plus sin inverse 1 minus x is equal to cos inverse x, where x is not equal to 0. So in the solution, first of all, in RHS, cos inverse x will be changed by the formula sin inverse x plus cos inverse x is equal to pi by 2. Cos inverse x will be written as pi by 2 minus sin inverse x. Then from LHS we will transpose sin inverse x to right hand side. Then on right hand side, sin inverse x and sin inverse x will be added together. It becomes pi by 2 minus 2 sin inverse x. Now sin inverse x will be transposed to right hand side. It will be changed to sin pi by 2 minus 2 sin inverse x. And we know that sin pi by 2 minus theta is equal to cos theta. So it can be written as cos of 2 sin inverse x. Now we will apply the formula of 2 sin inverse x, which is in terms of cos inverse. So its value will be cos of cos inverse 1 minus 2x square. Then cos inverse will neutralize to each other, which will be equal to 1 minus 2x square. Now we are getting a quadratic equation in x. So on factorizing we have two values of x here. One is x is equal to 0 and other is x is equal to 1 by 2. But according to the question, x cannot be equal to 0. So x is equal to 1 by 2 will be considered as the solution. Children, I hope you have understood the concept of inverse trigonometric functions. So now you can try the questions given in your textbook. Thank you very much.